In this video we are going to look at some more calculations with moles. We need to remember the formula triangle that we already talked about in the last video, where we have mass at the top and relative atomic mass or relative formula mass times moles at the bottom. In the example we are going to look at, we have 1.4 gram nitrogen react with 4.0 gram hydrogen to form ammonia. This is the balanced equation. N2 plus 3H2 reacts to 2NH3. And the question is, which is the limiting reactant, nitrogen or hydrogen? The equation shows that 1 mole of nitrogen reacts with 3 mole of hydrogen. So to find out which reactant is limiting, we need to calculate the moles for nitrogen and hydrogen. So we are going to start with the nitrogen. To calculate the moles, we need to take the mass and divide it by the relative formula mass. And for nitrogen we are given 1.4 gram in the text, so we can plug this into our equation right away. And then we need to calculate the relative formula mass for nitrogen. Nitrogen has an atomic mass of 14, and because there are 2 nitrogen atoms in a nitrogen molecule, we get 2 times 14, which gives us a relative formula mass of 28. We can now plug this into our equation. So we get 1.4 divided by 28, and this gives us 0.05 mole of nitrogen. Now we have to do the same again for hydrogen. For hydrogen the mass is given as 4.0 grams, so we can plug this into the equation right away. And again we have to calculate the relative formula mass. In each hydrogen molecule we have 2 hydrogen atoms, and the atomic mass for hydrogen is 1, so we get 2 times 1, which gives us a relative formula mass of 2. We can now plug this into our equation and we get 4.0 divided by 2, which gives us 2 moles for hydrogen. Now to decide which reactant is limiting, we need to look back at the balanced equation, where we saw that 1 mole of nitrogen N2 reacts with 3 mole of hydrogen H2. So if we take the 0.05 mole of nitrogen that we have, that would mean that to react this completely we need 0.15 mole of hydrogen. However, we have much more hydrogen than that. We have 2 mole, so hydrogen is in excess, we have much more than that, and this means that nitrogen N2 is the limiting reactant here. Now we're going to stay with this example, with this reaction, but we're going to change the question. The question now is, calculate the mass of ammonia formed. We already found out that nitrogen is the limiting factor, and we have 0.05 mole of it, and this means that we can form maximum 0.05 mole of ammonia. We cannot make more ammonia than that. So we already have the moles now. To calculate the mass, we need to take MR, relative formula mass, and times it by the moles. The moles we know is 0.05, because 0.05 mole nitrogen are the limiting factor. And now again we need to calculate the relative formula mass MR. This time we need to do this for ammonia, and in ammonia we have 1 atom of nitrogen, so we take 14, which is the atomic mass for nitrogen, plus 3 times 1, because we have 3 hydrogen atoms. And this together gives us a relative formula mass of 17, which we can now plug into our equation. So we get mass equals 17 times 0.05, and this gives us a mass of 0.85 gram for the ammonia that we can form in this reaction.